Number 4, we're given the figure of f, and we're told that f is the integral, of from 2 to x of g of t dt. Which of the following could be the graph of g of x? Well, let's get g of x for starters. We know that if we derive f, then that means we're going to find the derivative of this expression, which means we're going to replace t with x. So g of x is the derivative of f. This is the graph of f. So basically we're given the graph of a function, and we want to find out what is the graph of the function's derivative. Because again, g is f prime, so what could f prime look like? Well, the derivative is the slope of the tangent to the curve. So let's look at this. We don't have a curve, we have a line, and that line is always with a positive slope. And that slope might be a half or a third or a sixth for all we know, because we don't have the scale available to us, but it's constant. All right, and therefore we want a function that represents our derivative that would be constant. Well, there are two of them, a and b. All right, c is not a constant function, it's got linear growth. And then d and e both have curvature, so they are definitely not constants as well. Constant functions are horizontal lines, and that's the situation with a and b. But we said before that this function has positive slope, so therefore the derivative should always be positive. With b, the answer for the derivative is always negative, but with a, it's always positive, so that's our solution. For number 5, we have the integral from 0 to x of sine t dt. Now, many students right away want to choose option A, because they say, oh, I replace the t with the x. But this is like one of those games of Simon Says. All right? There is no derivative out front. So Simon didn't say to derive. In fact, we want to perform the fundamental theorem of calculus, which says that we do the antiderivative, and then we plug in x and 0. The antiderivative of the sine of t is going to be negative cosine t, and that's going to be evaluated from 0 to x. We plug the x in first, so we have the opposite of the cosine of x, minus, and then we have the opposite of the cosine of 0. Well, the cosine of 0 is 1, and we're going to negate it, so we have the opposite of the cosine of x minus negative 1. Double negative means a positive, so we have the opposite of the cosine of x plus 1. And another way to write that is to change the order. The 1 is still positive, the cosine is still negative, so our answer is E. Flipping over with number 6, g is a certain function, and g prime is the integral from 0 to x of e to the negative t squared dt. Which of the following must be true on the interval from 0 to 2? All right, well, we see increasing, decreasing, concave up, concave down. That means that we are looking at first derivatives and second derivatives of g. Well, we have the first derivative of g. Let's also quickly get the second derivative of g. And we can do so, again, by replacing t with x. So we have e to the negative x squared. That's the second derivative of g. So which of the following must be true? Well, the second derivative is a function about e. We know that no matter what, e is always above the x-axis. All right, and if we change, this is e to dx. If we change the exponent around, okay, it might change the direction in which the function is going. In other words, we might be decreasing instead of increasing. But our function is still never going to be negative. And if the second derivative is always positive, that means that our function g is always going to be concave up. So E and D and B are out. Now we have to determine whether g is increasing or decreasing. Well, that goes back to the first derivative. The first derivative is the integral from 0 to x of e to the negative t squared. And we're interested in the interval from 0 to 2. So that means we're not going to be going backwards where we have to swap the bounds. All right, 0, we're bigger than 0, so that means that every upper bound value of x is going to be bigger than 0. We don't have to change them. So now we're looking for the area between the function and the x-axis. Well, again, our function is this something like this blue curve. And that blue curve is always above the x-axis, which means that we're going to have some area, and it's always going to be positive because that region is going to be above the x-axis as well. So g prime of x is also always going to be positive, which means our function is always increasing. We said already that our function is going to have to be concave up, so our answer is A. Number 7, we're given this graph of g. We're told that g is the integral from a to x of f of t dt, and x is between a and b. So we're only interested in this domain right here. We have the graph of g, and which of the following could be the graph of f? Well, f's over here on the right. We should probably figure out what's going on here. Again, we're using our fundamental theorem of calculus. Can we get f of x? Yes, we can. If we take the derivative of g, that means we have to take the derivative of this side as well, which means we plug in x for t. So f of x is actually g prime. So we have the graph of g, and we're interested in the graph of f, but f is g prime, so we're really interested in the graph of the derivative of what we see right here. So, what do we have for our graph of g? The graph is increasing, and then the graph is decreasing. That means that our derivative should be positive when our graph is increasing, and then our derivative should be negative. This is what should be happening to g prime. We need a graph of g prime, which is the same thing as f, and that graph should be positive and then negative, because our function increases and then it decreases. It doesn't really change whether it's increasing or decreasing any other times. So let's go look at our 5 choices. Do we have a graph which is positive and then negative? Well, A is positive and then it's negative, but then it's positive again, so that's out. B is negative and then it's positive. We want it the other way, so that's out. C is positive and then negative, so that's in. D is always positive, that's out. And then E is negative and then positive, so that's out as well. The only answer that fits is C.